All right, so we're going to graph lines, reviewing first. So just kind of walk through these with me. So as we start, here we go. Negative 2x plus 4. Talk to me here, Zach. What are we going to do as a line? Go up to 4. And then what's our slope?
-2.
So we go down 2 over 1.
Yep.
Okay.
Why would you do that?
Then we go the opposite direction. Choose your line option. And drop it in. So the two key ideas there, as you're looking at them, are you have slope of -2 and the y-intercept of 4. All right? Let's come over here. Number 2. Slope, -2/5. Y-intercept of how much? 1. So start at 1. Everybody go down 2 over 5. And then do that backwards, up 2, back 5. Draw our line. And I do need to remember to put arrows on our line for both of these. Okay. Number 3 is a question from our test. Remember, y equals goes through the y-axis, all the points where y equals -2. So just put a bunch of horizontal dots there, because all of those dots represent where y equals -2. Little reminder, what's the slope of this line? Careful.
0.
Slope is 0. No slope is what kind of line? Vertical. Okay. And the y-intercept here is -2. Okay. Throw some arrows on here. Did you see the crosshairs at the beginning? That was really weird.
Yeah, I did.
I was like, what are the crosshairs going here? All right. What's my slope up here? 1/3. What's my y-intercept? -2. So start at -2. Go up 1 over 3. I would like you to dot as many dots as you can on each graph that we're given. Do you guys know how to draw lines, by the way?
Yeah.
Using the drawboard function? Just you select the line shape. Okay. So we put our arrows. Paul, this is your specialty. X equals 3. What is the slope?
Undefined.
Undefined. Okay, so the slope is undefined. What's the other name for it, Madeline? Do you remember?
Isn't that just sound like no slope?
Yeah, exactly that. No slope. If I could spell slope. Okay, so we don't say 0. We don't, it's just that. Now, remember that is everywhere where x equals 3, so put a bunch of dots where x equals 3. And very quickly you see that's a vertical line. Boom. Don't forget your arrows. We always say there's more off the graph than there is on the graph. Okay? So there we have a number of different graphs as a very quick review for those of us who are kind of trying to work through that of all the stuff. Now down here in the bottom we've got some summary. mx plus b. M is the slope, b is the y-intercept. Slope can be thought of as the rise over the run or the slope. We're going to start with the y-axis, plot enough points to fill the graph, put arrows at the end of your line, and remember x equals a number is a vertical line, y equals a number is a horizontal line. So that's just kind of a big picture review of lines in general. All right, so let's move on. How quickly can we do these? All right, go ahead and do them with your partner. I'll do them up here. And if you get stuck, just look up. On each one, write your slope, write your y-intercept. Okay, on each one, write your slope and your y-intercept. Don't forget your arrows. All right, once you're done, compare against mine.
Is your first one wrong?
Possibly.
It's not negative, so it would be.
My first one,
Yeah.
number 7.
Yeah. So it would be on the other side.
No, I start at positive 4, and I go up 1 over 2, or up 1 over 1. Remember, you always start on the y-axis. Always start on the y-axis. Curious, who went 6 for 6 there? Anybody? Nice. Nice. We good there? Is that a good quick review? This would be a great sheet to pull up just as a blank to really quickly review graphing lines. If you could do these 12, you can be considered yourself a master in terms of just all of those possibilities. So if you were reviewing later, pull up the blank, graph them, see how you do, and bada bing, bada boom, and you've got it. All right, let's move in then and kind of jump from here. Let's talk about solving systems by graphing then. Here we go. We've got to graph these 2 lines. I'm going to graph the top one in green. So I start at positive 3. My slope is negative 1. So I'm going to put dots all the way down. One of the things that I noticed on the test, guys, is some of us were not extremely accurate as we could have been all the way between our graphs. So I want you to really work on really making sure your lines are consistent all the way across your graph. I'm going to graph the other one in blue. So we start at negative 2. I go up 3 over 2. Up 3 over 2. Stop. Freeze. Do you see the fact that my lines have already intersected? I need to go no further because the purpose of this is to determine where the lines cross. Have they crossed? Yes. Okay, so I'm going to draw my line. Boom. Obviously, where do they cross?
2-1.
Okay, so they cross at the point 2, 1. So the point 2, 1 is our solution. Okay? If we were to check that, we would go up to the top and we would say, hey, plug in the number 2, 1. Does 1 equal negative 2 plus 3? You bet. Does 1 equal 3 halves of 2 minus 2? Well, 3 halves of 2 is 3, and 3 minus 2 also works. So, does it check for both? Yes, and that's why it's a solution. So 2, 1 is our answer. The goal is not the graph. The goal is where do they cross, Joey? That's all. So we found where they crossed. And I was just checking by plugging my values in up there at the top. Let's slide over to B. I created B intentionally in order to force us to first, Paul, change them into slope-intercept form. And so let's just make a little note that says change into y equals mx plus b.
Why can't you just graph it straight from standard notation?
You could do x and y intercepts. That's a possibility. Typically, that's harder for people, but you could. If you want to plug in zeros and find the x and y intercepts, that's fine. I'm going to just flip it quick. So I get negative 2y equals negative 2x plus 4. That gives me y equals 1x minus 2 for my first one. And my second one, I add x, and I get y equals x plus 6. So I just prefer to go to y equals mx plus b. But if you want to do standard form, perfectly fine. All right, so let's graph the red one. I start at minus 2. I have a slope of 1. Putting my dots up and down my graph because I'm looking for where they intersect. Struggling with drawing my line here. All right, my second one, x plus 6. 1, 2, 3, 4, 5, 6. 2, 4, 6. My slope is 1. Draw my line. So where do they intersect?
No,
They don't. Is that a viable option?
Yes. Yeah.
Okay. So you might have a situation where they don't intersect. And so in that case, very simply, we're going to say, hey, no solution. And the reason why is the slope is different. Sorry, what am I saying? The slope is the same and the y-intercept is different. So look for those kind of situations. If you have the same slope but a different y-intercept, you're going to end up with no solution. So that's a possibility. Is that fairly rare? Yeah. Situation A is much more common. All right, let's go down to C. I created C because sometimes when we have problems that are so straightforward, they actually end up causing issues. All right? On my first one, my slope is negative 1. My y-intercept, my b value is 0. So start at 0 and go down 1 over 1. And put your dots. Draw our line right through the origin. Really work hard to keep your line, Trevor, on the right angle, going through each 1 over 1, 1 over 1, 1 over 1, all the way down. Okay. Now we go to x equals 5. 1, 2, 3, 4, 5. Remember that is a no-slope equation. That's a vertical line. There we are. Do you very quickly now see where they intersect? What are the coordinates of the intersection point? What's that?
5,
Good. 5, negative 5. Thank you. That's where they intersect. Remember, our only objective is to find where the lines intersect if possible. Remember on part 2, they didn't intersect, and that's okay. That's okay. All right, moving on. So here we have our 3 situations. We've kind of done them so far. First intersection is called independent, and it's when you have one solution. So let's write the characteristics there of an independent situation. All right, we have the slope is different, and the y-intercept may be different. By saying may, does it have to be?
No.
Okay. With a unique situation, in other words, you have the same line exactly, they have the same slope, and they have the same y-intercept. And then our third situation, where they're inconsistent or no solution, they have the same slope, but they have a different y-intercept. So we did situation parallel lines and intersecting lines. We did independent and inconsistent. but we didn't do a dependent situation. Now, I just need you to pick up on the fact that those three words, independent, dependent, and inconsistent, those are new words for us. We didn't do those in Algebra 1. All right? We did one solution, no solution, and infinitely many solutions. We talked about how many. And now it's more of a word classification. So I just need you to kind of pick up on those words and realize that if it says, what kind of solution do we have? You might respond, oh, this is an independent one, which means there's one answer, okay? Right now, you guys are dependents, okay? Wherever your parents live, you live. But at some point, after college, you're going to move out, okay? And your parents are going to live one place, you're going to live another place. And that's when you are be called as an individual, you're now independent, okay? You have a different situation that's going on. And so an independent solution, has its own situation, but a dependent solution is coinciding, okay, cohabiting with your parents. Okay, that's how I kind of remember those. All right, so let's look at these down here, and we're going to classify them as independent, dependent, or inconsistent. Remember, independent means they have different slopes. Okay? Dependent, remember, means the same slope, same y-intercept, and inconsistent means same slope, but different y-intercept. So to figure this out, for each one, we're going to have to very simply figure out their slopes. So cut this up, and we're going to take each one. I'm going to kind of turn this into a grid. Here's my top one, 4x plus y equals 8. All right? Do you agree that that ends up being y equals negative 4x plus 8?
Yeah.
Okay? I'm going to go to my bottom one. Do you agree that that becomes 3y equals negative 12x plus 9 so far? I divide by 3, and I get y equals negative 4x plus 3. What is the same in these graphs? Same slope. What is different? Y-intercept. So let's go up and compare. Same slope, different y-intercept. Therefore it is what? Inconsistent. That means the lines are parallel. Let's look at B. Well, B is really easy. Y equals 3x minus 7. That was simple. The bottom one, who can move that over for me? 2y equals what?
2y equals 6x minus 14.
Okay, 6x minus 14. And we divide by 2. Y equals 3x minus 7. Is anything the same?
They're both the same.
Both the slope is the same and the y-intercept is the same? So that comes up, what kind of? Dependent. Okay. Dependent. Boom. All right, let's look at the third one. Negative y equals negative x plus 3. Y equals x, what? Minus 3. Let's look at the other one. Y equals 5x minus 3. Is the slope the same? No. Nothing else matters. Because guys, look at my arms. The slope is not the same. It could be anything like this, but anything like that, are the lines going to cross? Okay, I don't care where. All I'm answering is, do they cross? And so, Sebastian, it's just a case of, yes, they cross. So therefore we have...
So when they have the same y-intercepts, they always cross on the y-intercept.
Yes. Unless they are a unique solution where they have the same line. So you have to look at the slope first. So in this one, it's just independent. And that's it. Okay? So we're really comparing slope first and then the y-intercept. And you're just determining, do they cross? If so, how many times? And where do they cross? Okay? All right. So here's our homework. Really straightforward. A big whopping 7 problems. All right? 118, 1, 3, 4, 8, 16, 17, and 29.
Easy.
Hopefully. All right, I will put that up on the screen for you because I believe some of you may not have that.